Hey everyone, so this video is going to describe how we can state the domain and range of piecewise functions. So we're going to look at two different graphs here and talk about how we are going to describe the domain and range of each of them. Okay. So something that you may remember from Algebra 1 when we talked about inequalities, you may remember looking at pictures and doing something like this where you would draw and then you might like shade part of this function or something like that. Okay, so shading, blah, blah, blah. You may remember shading a lot. Okay, so we're going to kind of use parts of that idea when we talk about the domain and range of a graph. So let's start with the domain. Remember, our domain is the set of all our values of x. Okay, so my domain, I always want to start with the leftmost side of my graph. Starting from the left, we read from left to right. So notice I have an arrow here. That means that this function is going to go on to the left forever, all the way towards negative infinity. It's continuously going to go towards negative infinity. So what we can say is that our smallest value of x is negative infinity. And we're going to put a less than sign in front of that because we can never reach infinity. Okay. So as I'm moving along now from left to right, I see that everything's okay. And then I get to a point right here. I notice that there's an open circle, but also that there's a closed circle right above it. Okay. So open circle means the point doesn't exist, but closed circle means the point does exist. So this is interesting. What would we say is our value of 1 here? Like, do we have a y value at this point? Yes, we do. We actually have our y value right here. So there's no break in the graph, okay, in our domain. Our domain is covered. So I can keep going and say, all right, well, I just jumped up to this function. I'm going to keep reading left to right. And we have the same situation. I have an open circle here, but I have a closed circle at the same x value. So because that closed circle is there at that x value, we're good to go. We can keep moving. Going to keep going from left to right. And I see that this piece of the function also continues to go on to the right forever and ever towards positive infinity. So because we didn't have any breaks in the domain, we can say that our domain goes from negative infinity to x to positive infinity. That's our inequality notation. If I wanted to write this using interval notation, we would put a parentheses, because this is a less than symbol, parentheses, negative infinity to positive infinity, and another set of parentheses. The other form that we learned was set notation. So this is where we are going to write a little squiggly, and we're going to say x, e, or this like C with a line through it, is in the set of all real numbers. And I'm going to draw this line. And I'm going to rewrite my inequality notation from earlier. All right. Those three notations mean the same thing for that domain. All right, let's erase and talk about our range. So now when we talk about range, we're looking vertically. So down here we have negative infinity, up here we have positive infinity. So one thing I notice is that the lowest y value that I have is actually at negative 6. But you'll also notice that at negative 6, this is an open circle. So that means that y value doesn't exist. So what we're going to do is we're going to write -6, but we're going to put a less than sign in front of it. Now I have y. And now I'm reading my graph vertically. So now I'm moving up. And I notice that all my y values are taken care of. I don't have any point. I could draw a bunch of horizontal lines, and I'm always going to be touching some part of the graph. And because of that, we can say that our range goes from -6 to positive infinity. There's no y value, there's no horizontal line that I can draw that won't touch part of the graph. Okay. So let's rewrite this in our different notations. So this was our inequality notation. Notice that I have a less than sign here, so I'm going to write a parentheses, -6 to positive infinity. I have another less than symbol, so I'm going to put a parentheses around that as well. Okay, and then finally in my set notation, our brace y is in the set of all real numbers, and this goes from -6 to y to positive infinity. Okay. All right, let's try our next one here. So our domain. So I'm going to use that idea from before. If I can draw vertical lines on my domain, because I'm trying to make sure I can cross the function. So if I draw vertical lines on my domain, notice that this arrow keeps going on forever. It's going to keep going on forever to the left. So I know that's going to be at -infinity. So that's where it's going to start. My domain is going to start at -infinity. And then I notice that as I'm moving along from left to right, I come to a break in my graph. And this break happens at -5. So my domain is going to go from -infinity to -5. Notice that this is an open circle, so I'm going to have a less than sign. And I also have another piece of my domain, because it's not just that one piece, but we also have this piece. And this piece starts at 0, and it keeps going on forever and ever to the right towards positive infinity. So I have to write another interval, or another kind of inequality, that's going to start at 0, which is less than or equal to. Remember, I write less than or equal to because this is a closed dot, which is less than infinity. So that whole thing, this whole thing right here, is my domain. Let's write the same domain using our interval notation. So starting with -infinity, I have a parentheses around -infinity, and I go from -infinity to -5 with another set of parentheses. Now because I have two pieces, I need to also write my other inequality. And I shouldn't have drawn a parentheses because this is less than or equal to. I need to draw a bracket, and that goes from 0 to positive infinity. Lastly, if we do our set notation, x is in the set of all real numbers, And we can say x goes from negative infinity to negative 5. And I can maybe do like a comma or a semicolon, and then 0 to infinity. All right, let's talk about our range. So range, going from negative infinity to positive infinity. So if I look at my range, I see that both of these functions go all the way down to negative infinity. So we can start there, negative infinity. Remember that it's range, so I need my y value. And then I'm going to look at my highest y value. And right now, this looks like it is at positive 5. But I need to notice that at this point, positive 5, that's an open circle. So that point is not included. So I need a less than sign. All right. Luckily, this range only has one piece to it. It's not split up into multiple pieces. So my interval notation would be parentheses, negative infinity, comma, positive 5, parentheses. I'm using parentheses because both of these are less than symbols. The last piece is my set notation. So y is in the set of all real numbers from negative infinity to y to positive 5. All right, there are 2 examples of our domain and range for piecewise functions. So go ahead and try those problems in your unit review.